Let's talk about the most expansive, expressive, and conspicuous organ system in the body, and that would be the integumentary system. The integument is the skin, which includes the epidermis, which we see in green right here, and the dermis, which we see in violet. Below the dermis, we have the hypodermis, which is adipose tissue. The dermis is connective tissue, and the epidermis is stratified squamous epithelial tissue. Keep in mind, as we discussed with epithelial tissue is avascular, so we will see the blood supply, which provides nutrients and oxygen to this overlying epithelial tissue. The blood vessels are within the dermis. One thing you should notice here with this epidermis is that it is stratified squamous epithelial tissue. And at the bottom of this epithelial tissue, these cells are cuboidal or columnar in shape, whereas the ones towards the apical surface are flattened. You can see the nuclei here are flattened or squashed. When we are identifying or naming stratified squamous epithelial tissue, as in any tissue, cell shape is one of the components of the naming of epithelial tissue. And there are different cell shapes within stratified epithelial tissue. We always utilize the uppermost or apical cells to identify it. So because these cells on the apical layers are squashed or squamous, we refer to this as stratified squamous epithelial tissue, even though the basal layers have cuboidal and columnar cells. Let's talk about the function of the integumentary system, which once again is the largest organ system in the body. One function of the skin or the integument is to serve as a barrier from the outside world, preventing things, pathogens, objects, water from entering our body. So by and large, we're impervious to things entering our body or leaving our body. We are not losing water over the course of a day, or at least we're not losing a large degree of water over the course of a day, nor are we taking in water. Another function of the integument is a low pH. A neutral pH is 7. The pH of our skin is roughly 4 to 6, referred to as an acid mantle. Any pH between 0 and 7 is acidic, and that helps deter any microorganisms trying to enter our body. And as far as microorganisms, we also have immune cells within our skin known as dendritic cells, which activate our immune system and help promote our adaptive immunity. The sun is significant to our livelihood for a number of reasons, but one is for calcium absorption. Calcium absorption is necessary because we need calcium to build bones, but we need calcium for all sorts of underlying functions within the human body. Absorption of calcium is dependent upon vitamin D in the body. And vitamin D synthesis is initiated by the sunlight, specifically the absorption of UV rays by the skin. Now, this whole process is finished in the liver and the kidneys, but it is initiated in the skin by the absorption of sun rays. We also have sensation as a huge role of our skin. That is to say, we can feel texture, something fluffy, something coarse, something hard. We can feel pressure. If we're pushing against something, if we're squeezing a ball, we can determine how hard or how soft to hold something. We can feel heat. We put our hand on a hot stove, we can sense that. Or if we put our hand on a block of ice. And lastly, we have thermoregulation. Like I showed, there are blood vessels in the underlying dermis below the epidermis, and those blood vessels will vasoconstrict in cold weather to prevent us from losing heat. And during warm weather, those blood vessels will vasodilate or get larger to release heat. We'll continue on and talk more specifically about the different layers of the integument and the underlying hypodermis.